it is actually a aeroplane. Okay, so aeroplane is also called as a fixed wing operations, and we'll see how the aerodynamics effects on it. Okay, so what are fixed wing drones? Fixed wing drones are the aeroplanes which generates lift under the wing due to the forward airspeed, which is produced either by internal combustion engine or by electric motor mounted with the propeller. Okay, so you will always have a combustion engine over here, or probably a electric motor. Okay, so either of these two engines would be there with a propeller, which will produce a forward airspeed. Okay, and then it will create a lift under the wings. They will require either a hand. I mean, they are either uh, launched using either a handheld catapult or runway to take off, and can fly continuously over longer distance as opposed to the hovering wing.
Hovering.
So if you see, there is a person who is actually holding it in hand, he will just throw it in the air, or there would be a catapult mechanism where it will, spring loaded, it will be there and it
Yeah.
will land it. Or probably like a predator drone where it has to run on the runway and take off. But in this, any of these aeroplanes or airplanes will always require to continuously fly. It cannot stop, it cannot hover. That's the one of the limitation of the fixed wing. But as these airplanes are required to cover a larger area, larger distance, it's
Hmm.
okay for this thing. Whereas if you see what we call the drones, their operations is limited with the what we call limited with the operations. Like they are limited in a range or within a,
Limited altitude and
yeah,
the range capacities.
lateral motion is very limited.
Okay.
Okay. So there are different types of fixed wing drones based on the wing type. So there is a rectangular straight wing, tapered straight wing, or round or elliptical straight.
Elliptical string.
Okay. So if you see the straight wing, the wherever you don't see the shape is very very rectangular in shape. That they are the very less efficient. Whereas as you change the shape, you angle the tapered kind of thing, you do it. So probably they will improve the efficiency. But whenever you have a rounded or elliptical, like you will see most of the time, more stable aircraft are always in a elliptical or rounded
Elliptical round.
shape. So if you see the aircraft during the World War II, like Spitfire or
Yeah.
Mustang, those you see their tails or their wings, they were more like a round shape, more
Yes.
elliptical kind of thing. So they were more efficient. Okay, if you have a square or rectangular shape or sharp edges, especially the sharp edges, so everything needs to be angular. Everything needs to be round in shape. So that's where you get more efficient. Okay, if you have somewhere tapered or rectangular or sharp edges, your wind will try to cut over there. Okay, it will not have a smoother motion or smoother movement
Yeah.
of airflow. Okay, that's what it is telling. Okay, then there is another called swept wing. Okay, where you have an angle. So slightly swept wing, moderately swept wing, and highly swept wing. So you can see here depending upon different. So bigger airplanes, the airplanes which has a very big fuselage and all the thing, there in those you will always see what we call as swept wind shapes they are being used. Okay,
Yes.
depending upon the functionality, the length of the fuselage and the performance and all the things. So combination of these are being used, whether you want to use slightly swept, moderately swept, or highly swept.
Highly swept.
Okay, whereas the last one is the delta. Okay, delta basically is used when you are actually flying a drone at very very high speed, especially like you will see this kind of wings in a fighter planes or bombers, where they have to cover a distance in a very short time. Like simple delta wing would be like a
Yeah.
triangle.
Usually the supersonics.
Supersonics, yeah, supersonics or subsonics kind of thing. So suitable for high speeds, okay, subsonics or supersonic flights. So in that scenario only you will have this kind of delta wing ships, what we call.
Yeah.
Okay. So if you see the part of the fixed wing, okay, it is similar to like an aeroplane. So you will have a wing with the ailerons. you will have a vertical
Stabilizers.
stabilizer where you have a radar. Then you have a horizontal stabilizer where you will have elevators. Okay, then you have a fuselage similar to the aeroplane. You will have a engine with a propeller. Okay, engine or motor with the propeller and the wings to glide. And then if you see on the belly of the fuselage, you will see something, a device, a mechanism where you can put up your payloads. You can put cameras and all things. You can put even, where if it is not for monitoring purpose, the fixed wing, if you are putting it for dropping the bombs or anything, you can also have attached bombs below this. Okay,
Yeah.
so that's how the part. So similar to your aircraft or aeroplane, the structure of a fixed wing UAP is more or less similar. So it will have elevators, radars, and ailerons for controlling or maneuvering the aeroplane, whereas it will have a twin engine or multi engine. It could be to give the thrust. Okay, either it could be powered using IC engine or it could be a bigger engine. Normally you can't use electric in this scenario because you will not get endurance over here.
Yeah.
Okay, so it could be powered by different fuel engines would be there. Okay, so what is the components of the fixed wing? One is the propulsion system, then the fuel system, the control system, the avionics, takeoff and landing system. So takeoff and landing is nothing but your wheels. Okay,
Understood.
and then you have a payload system. So under the belly, as I said, you have, you can connect cameras, lidars, all the surveillance type of devices you can put it. Even the radars are there so that it monitors where it is flying, and it is getting proper signal from the ground station, and it is able to function as required. Okay, so let's see from the propulsion system what we have. We have two types of propulsion system. One is brushless direct current motor, or we have a IC engine. So either of these two will be the propulsion system. So when we have a brushless, we have a high power to weight ratio available in wide range starting from 5 grams. Best suited for nano or micro categories because small unmanned aeroplanes you can make, not the
Like
bigger ones.
toys. Right.
Yeah, like toys, right? Or aero modeling, like we do it in aero modeling. So
Okay.
there we can use this kind of propulsions. Okay, best suited for nano micro categories. Low noise helps in keeping the low profile in the stealth operation. I mean, you can just fly close to the border area if you are using this kind of things also. They will not be gaining very big height or something like that. But
Mm.
if you are looking for a high endurance, high capacity and all, so conventionally used system. So basically you have a IC engines, internal combustion engine, okay, provides high endurance than BLDC. That is brushless direct current motors
Yeah. Yeah.
suited for medium or large category. I mean, it is not category, it is a class. Okay, best suited for medium or large class. IC engines are, however, noisier than BLD. But then, if you see you are using IC engine, they will be flying at 20,000 feet. So you will not able to hear that noise also. Though their noise, because noise will be only audible when you are near the ground or you are on the runway. But when it is in 20,000 feet, you will hardly could hear the engine noise also from that location. So 20,000 feet is almost like 20 kilometer. From 20 kilometer, that sound has to come and hit my eyes. So it is sorry, ears. So
Sir, are
that
you
will be a
there
very
or is there
difficult to
any
hear
connection
more
loss?
unless it's really very big noisy engine. So it is noisier then, but compared to BLDC is a very quiet moment. Okay, no noise, nothing comes from the BLDC motors. It will only come because you will hear the noise only of the propeller, but that propeller noise will be always there, even any of this, whether you use BLDC or you use IC engine. Okay, now for both the propulsion system, you will have to use propellers. So these propellers are either connected to BLDC engine, BLDC or IC engines, provides thrust by rotating in size, particularly the direction. So the motion of the propeller will cause the thrust. Either it is made of wood, industrial and small grade plastic, or maybe carbon fiber. So
Usually very lightweight.
very lightweight, yeah, but strong. Only
Understood.
it has to be light, but it has to be strong. So wood was primarily used during the World War, but later on they moved to the aluminum grade, the high quality aluminum grade, and then recently they are using carbon fibers because
Okay.
it's very that stencil stress is very high of carbon, and then it is very super light also. Okay. Whereas, let's see what are the fuel system used. So, lithium-based batteries are used for the electric motor. So, either it could be lipo or it could be lithium ion are the most widely used batteries. So, lipo batteries can be custom built for different shapes and size. Lithium ion batteries are capable of higher endurance flights. Energy density is far less compared to IC engine. So, that's why density of the energy, I mean, amount of the endurance what you get or the amount of power it can carry by the liquid foil is less in lithium based batteries. So if you see liquid based IC engines, the liquid is stored in a tank mounted in fuselage. Okay, it could have a glow nitro fuel or gasoline or even diesel is used. Best thrust to weight ratio than lithium based batteries. So here, power is more, the torque what it gets. So so bigger. So that's why if you see here, it is very clear what it where it is used for medium and large, whereas here it is nano micro, and in both category you can have a small class also. Okay, so
Okay.
depending upon usage, mostly the IC engines are used in medium and large class. Okay, so liquid. What are the other alternatives? It could be like not about the lithium based, not about the liquid fuel, but there are some now,
Hydrogen or solar power.
hydrogen power or solar, but these are as of now in a testing phase. They are
It
not
is about future now.
future. Yeah, future people probably you would have a fixed wing based on hydrogen power or maybe on solar panels also. Okay, so now when we are flying these drones, okay, the fixed wing drones, we need to know how to use the remote control. Okay, so in case you are able to understand the remote control, you see there are two joysticks on the remote control. Any remote control you see or RC, transmitter, which will have a two joysticks, one on the left side and one on the right side.
Okay.
So ideally, when you are holding in your hand, it starts with your right side. Okay, so right side is R. Okay, so how do you remember? R for right side, R for roll. Okay, and
Okay.
then we talk about we are learning a drone flying in RPTO. So it is called RPTY. You are
Okay.
replacing O with Y. Okay,
Okay.
RPTO. So R is roll, P is pitch,
Pitch.
then on the left side you have throttle, and then you have last is yaw on your left side. So on right side you have roll and pitch, on your left side, sorry, on right side it is roll and pitch, on left side it is throttle and yaw.
Yeah.
Okay, so your pitch and throttle, they are always up and down movements. Okay,
Okay.
whereas your roll and yaw are always lateral movements, okay, of the sticks. So if you see here roll, you can move like this. Okay, so roll right, roll left. Okay, so if normally we call it as roll right, so as you move the stick on the right side, you will perform a roll right. I mean you will bank on the right side. Okay,
Okay.
when you say roll left, you are like you move this red stick here this side, you will have roll left.
Left. Okay.
Okay, like you have a pitch, now the same stick you move up, it will move pitch forward, it will
Okay.
forward direction, whereas you move the stick back, it will
It
call
will
as
go back
pitch
to the
back,
direction.
so your drone will come back. Okay, now same goes for on the left stick. Left
Okay.
stick, your up and down movement is throttle. So as you move up, your drone will climb up. As you move throttle down, your drone will come down. Okay, when you do lateral movements, you means yaw means rotate your drone clockwise or counterclockwise,
Okay.
allowing you to make circle or pattern in the air. So normally using yaw and pitch motion, we will always control or we make the patterns. We can make circle or we can make square. All that things we can do it. Okay.
Got it.
So basically, yaw is the option when you use last. Okay, because yaw here you are changing the direction. Okay, so when you mixed yaw with the pitch, okay, in that scenario, you are giving yaw means you are turning as well as you are pushing forward. So when you have connect
Pushing or going back. Got
going
it. Got
forward,
it.
forward. Okay, so pitch is always saying
तो
forward.
ये गाड़ी ये बेसिकली गाड़ी जैसा हो गया
Ah,
कि आप उसको एक डायरेक्शन दे रहे हो और फिर आगे या
ah, you
पीछे
are turning also. So you are putting accelerator, pressing the accelerator, as well as you are turning the steering also.
गॉट
Okay,
इट
so yaw is with the steering. Okay, you are changing the heading, allowing you to make the circle or pattern in the air.
Hmm.
Okay? So normally roll is not used in drone, okay, or even aeroplane. Roll is very lessly used until unless you have to roll, you have to bank, then only you will use roll.
Okay.
Maximum time you will use either pitch or yaw.
Okay.
Throttle is only to change the height. Like
Yeah.
आप 10 feet पे हो, आपको 20 feet पे जाना है, then you will give throttle. But normally in drone motions, you will always have a particular height you will be flying, like 10 feet, 20 feet, or 15 meters, whatever you decide based on your. Normally, we try to see we are flying a drone at the eyesight level. I mean, I'm able to comfortably standing without straining my leg. I will try to see the drone. ज्यादा ऊपर करे तो क्या होगा, आपको नेक ऊपर करना पड़ेगा, नीचे आएगा तो इट विल बी क्लोजर टू द ग्राउंड, विच विल अगेन
समझ गया.
difficult. So you have whenever you're flying a drone, you at a comfortable position that you are not putting pressure on your body.
Got it.
Okay. So this drone, this remote control, whatever the configuration you are seeing, on the right side you have your roll and pitch, on your left side you have throttle and yaw. This is called as mode 2. Okay, this is called as mode 2. If
Okay.
you reverse this, okay, if you have a roll and pitch on your left side and throttle on your on right side, it is called mode 1. Okay, so mode 1 is normally used in US. It's similar to your left and drive and right and drive.
Okay.
Okay, so normally we always, like, India or Asian countries, they all follow mode 2, whereas US, Canada, Australia, maybe in Australia also some people use it, depends upon, people use mode 1. Okay, so if you see this remote control, you have 4 channels. Okay, like one is your roll
समझ
channel.
गया.
Channel 2 is your pitch. Channel 3 is throttle, and your channel 4 is yaw. Then there are other switches, other controls are there. Like you can have a remote control with 8 channels, 10 channels, 12 channels, 16 channels, like that, multiple channels for multiple different activities, different functionalities there. Like
Yeah.
like for example, there would be a switch. I can configure these switches. Apart from these 4 controls, I can still configure these controls also, but these switches are for specific purposes, okay, or specific requirements. I can always configure these switches for different purposes. Okay, just say I give example where you have a drone and you have a box below it filled with the flowers, and at a particular position you took that drone on the particular head of the wedding ceremony, and you just want to open. So one switch you can configure to open that box.
Got it.
Set signal you can
So
put a.
there are customizations options
Yeah,
also available.
yeah. So this LCD will actually help us to customize this remote control.
Okay.
Okay. So that's what we're saying. Again, roll on your right side, lateral movement, upward, front, forward is pitch. Okay. And then again, throttle up and down, and your lateral movement. So this is called mode 2 of your radio control. Clear on
Okay.
this? So
Clear, sir.
this is normally people do not know about it. Like, if I give a random drone, a random controller, or वो mode 1 में configured रहेगा, or sometimes it is inbuilt. It's inbuilt also sometimes. So normally in that scenario, people will not do, अरे ये इसमें ऐसा क्यों move हो रहा है, like इसमें मैं pitch करने जा रहा हूँ तो इसमें उल्टा हो रहा है and all that thing. So
Got it. Got it. So we have to first make sure that
yeah.
what are
So
the.
whenever you are flying the drone, you give a throttle, you fly up, you always check the controls by pitch. Pitch
Okay.
forward, pitch back, roll
Understood.
right, roll left, your right, your left. All those basic maneuvers you do at the position.
These are the basic
जैसे हम
safety
लोग
rules,
हम लोग
right?
गाड़ी चालू कर देते और एक्सीलेटर थोड़ा धीरे से देते, then we check the brake, we check the, whether we are pushing the clutch, but then it is becoming neutral, those basic checks what we do, right? So similarly here also we do those basic checks before actually performing our further actions or bigger actions on the drone. So that is called as a control checks when you are flying the drone. Clear?
Clear, sir.
Okay, now as we talked about autonomous drones, right? So whenever we have fly a drone in an autonomous mode, okay, so that goes into something called as a mission planning. Okay, so there is a software called Mission Planner. Okay, it's a third-party software, free open source software actually. Okay, it's basically a ground control station for plane, copter, or rover. it is only compatible, I mean, it is only available in Windows mode. Okay, so you can install that software, you can connect your laptop to your RC. Okay, there will be a connector connecting to your RC, or you can use a different device. A transmitter kind of device would be there, which will send interpret the signal from the your software. It will, transmit the signals to the drone, and then on the drone there would be a receiver for it. So if you have that setup, you can do it. If you do not have that setup, there would be a cable connecting from your RC to the laptop. So there is a
Okay.
special cable is required where you can connect, and then you can upload the plan. I mean, through you can make a plan in that software, and you can upload that plan, and which will become your drone as a autonomous vehicle. Okay, so like earlier, if you see earlier, drones doesn't had LCD panel. I mean, this LCD panel was only for configuring this RC. Okay, there right now, if you see the LCD panels on the control, it's like almost like a tablet. Okay, so in tablet you will have an option whatever you see on the laptop. I mean, you will able to see the control panel. You can see that software. I mean, you can down install that software. I mean, there is a version, mobile version of the software is also available, which you can install on that transmitter. And rather doing on the laptop, on the transmitter itself, you can configure your mission plan. So that means you can lay out your plan, how much height, what distance, what speed it should fly, and all that things it will capture. And once it is put into the autonomous mode, it will start flying, and it will start capturing the data. So data acquisition and area mapping would happen progressively. And once you have all this data, you can download on your laptop, and then you can do your data analysis. Okay, but
Okay.
all these actions will happen autonomously, not manually, because see, manually when we are flying the drone, it is not accurate, because all our controls are manuals. Like, it will not, like, if I want to keep a distance 3 meters between my two flight plans, I manually, because I'm at a far location. So what see I see from here 3 meters, and the 3 meters over there would vary. Okay, my eyes will not able to accurately interpret the difference between the two plans or two layout equal distances. Okay, so
Got it.
if you see here, like, if my drone is flying from this location, it takes off. You see how uniformly the motion would be. This motion I cannot perform manually. Okay, so for example, whenever I have a project to capture or do a land survey and all things, so they will give me the how much distance I have to be maintained between my flight plans, how much the detailing I want, how flight, I mean, how much overlapping images I would require. All that information will be there. So based on that, I will feed the data. I will create a mission plan. Okay, and then it will just fly on that particular location and come back with the data. So drones now have many functions, ranging from monitoring climate change to carrying out search operations for after natural disasters, or maybe photography, or maybe flying, all that things. Okay, just a minute.
Yeah, sir.
Okay, so but their most well-known and controversial is used for military. So initially, if you see the history of the drones, actually the unmanned aircraft was more or less used for reconnaissance, surveillance, or targeted attacks only. So as we flown the first aircraft by Wright brothers, and as after the development has happened, and Nikola Tesla showed that using the radio-controlled signal, you can control remotely the water boat in water. The thing was, technology was used so that you can fly the aeroplanes remotely controlled, and you can do reconnaissance, surveillance, or maybe perform targeted attacks on the enemy sites or enemy locations. Okay, so how do you take off or landing of the recovery system? Like, you can do a handheld launch, or you can use a catapult mechanism, or you can runway take off and land. Whereas recovery, that means landing, probably some fixed wing can also through the parachute recovery also. okay, or maybe net recovery, or there could be a zip line which can be capturing the drone, as there it is in flight. So
Got
it's
it.
little bit complex and risky also, because it will not be that smooth. Okay, whereas I feel the runway kind of thing is more stable and more safer,
More
because
reliable kind of a method.
reliable kind of thing. Okay, because here you are not, human intervention is very less, so you will configure it completely autonomous. It will run. Only thing your intervention is to bring the drone on the runway, and then you configure everything remotely. So maybe
Got it.
your drone may be somewhere at some remote location in Afghanistan or Iraq or something there, and your pilots may be sitting somewhere in US. Okay, so the physically they might just, the people might just bring the drone on the runway, and people will, once it is given the control back to the pilot sitting in US, they will take over and they will do perform all the checks. They will feed the complete mission plan and everything, and the drone will fly on the run. I mean, it will run on the runway and take off, and then further it will do all its activity, and then it will come and safely land on the tarmac or the runway. Okay, so what are the applications of the fixed wing is more of like surveillance, in mapping also, like agriculture mapping. A lot of time when we have to cover, like there was a project held by the Gujarat government where they want to map the complete Gujarat as a state for the agriculture part. Okay,
Okay.
so they had flown the fixed wing aircraft over the complete Gujarat region and captured the complete data of their state. Okay, or maybe wildlife protections if you want to, you know uh, like in Africa, or even wherever the big sanctuaries or
Even
forest.
Vantara right now is in the process of acquiring a whole big department.
Correct, correct. So then even construction sites, like you are doing a big construction, like constructing a dam, or maybe constructing road rails, in that scenario also, or maybe a big project where you are doing like mines monitoring,
Got it.
so in that scenario where the area is bigger, the small drone, the rotorcraft drone will not able to capture, because it has a very less height, as well as it is not able to capture the more area within that time frame. So see how many flights you would require to do if you want to cover, let's say, thousand acres of land. Okay, so that will not be done by a rotorcraft, so it has limitations. So every category will have its pros and cons.
Cons.
Okay, so what is the, let's see what is those pros and cons. So comparison of the fixed wing with the multi-rotor. So fixed wing is unable to maintain the fixed position. So it will keep on flying forward. Can only fly horizontally forward. Require hand or mechanical launch, that is catapult launch. But
Okay.
however, it's a longer average flight times, which means it will fly longer. It can also carry heavier payloads, like mean bigger payloads, bigger cameras, and all that things can be used using the fixed wing. It has great, because it's aerodynamically designed. It will have
Got
a
it.
great stability in the wind. Also, it will have a higher speed flights. That means it can fly at a very high speed. Whereas multi-rotor, easy to control and maneuver, have ability to hover. Okay, that means it can hold its position, can take off and land vertically.
Vertically.
These are the two important aspect or two important plus point of the multi-rotor. But it has limited flying time because of the battery. Okay, so
Yeah.
battery, still we do not have a battery where it will able to give a longer endurance capacity.
Hmm.
Again, if you put more battery, it will become more weight. Okay, so that will also add a challenge to us. So small payload capabilities, less stability in the wing, because these are not aerodynamically. It is only using propellers for the motion, only are using Bernoulli principles. For flying, it is following Newton's third law. Okay, but it is not flying aerodynamically. It is just a structure. It's just a frame. Okay,
Got
so
it.
it is less stable in the wind. So you will see drone lot of time drifting. Okay, and also has a lower speed flight. It cannot fly very at a very high speed. Whatever speed it can fly based on the motion of the motors, it can only fly up to that. Okay, so with that we complete our fixed wing operations and aerodynamics. So you have any questions on it? So if
No,
you see
sir. No,
fixed,
it's For
Yeah,
me, it's more of a like revision of my physics classes.
correct, correct. So it is basically like a refresher for you.
Yeah, I can say that.
Yeah. So now next topic is about the rotorcraft operation, which is more important, and this is actually our part of the training, and whatever we are going to use practically, what we are going to do. This is very important for us to understand.
Okay.